Saya Muhammad FIKRI HAKIM bin Awaludin, menteri nombor S56828 akan memberikan presentation berkenaan tajuk yang diberi, iaitu transistor IGBT, iaitu isolated gate bipolar transistor, IC integrated circuit, photon energy, photoconductive effect dan also photovoltaic effect. Okay, untuk transistor. Transistor is a 4-layer semiconductor rectifier in which the flow of the current between two electrodes is triggered by a signal at the electrode. A transistor usually has 3 electrodes, an anode, a cathode, and a gate. Transistors are primarily designed to amplify a rectifier and the electrical current that flow in high power electronic device. A transistor four layers consists of series of N and P type material that connect with the anode, cathode, and the logic gate. When a current is applied, the transistor allows amplified current and flow from anode to cathode. Although transistors can only transmit current in one direction, they have 3 different operating modes: reverse blocking, forward blocking, and forward conducting. The most common type of transistor is the silicon control rectifier, or SCR. When the cathode is negatively charged relative to the anode, no current flow until a pulse is applied to the gate. Then the SCR begins to conduct and continue to conduct until the voltage between the cathode and anode is reversed or reduced below a certain threshold value. Using this type of transistor, large amount of power can be switched or controlled using a small triggering current or voltage. IGBT. The isolated gate bipolar transistor, IGBT, is a functional integration of power MOSFET and BJT device in monolithic form. It combines the best attributes of both to achieve optimal device characteristics. The IGBT is a 3-terminal power semiconductor device primarily used as an electronic switch that can essentially combine high efficiency with fast switching, much like the MOSFET. And IGBT feature a significantly lower forward voltage drop compared to a conventional MOSFET in higher bucking voltage rated device. IGBTs are followed by a high voltage, high current, and low switching frequencies, while MOSFETs are better for handling a low voltage, low current, and high switching frequencies. The IGBT is a semiconductor device with 4 alternating layers, PN, that are controlled by a metal oxide semiconductor gate structure without regenerative action. The additional PN junction block reverse current flow. That means that unlike the MOSFET, IGBT cannot conduct in the reverse direction, in which circuit where reverse current flow is needed, an additional diode is placed in a parallel with the IGBT to conduct current in the opposite direction. The penalty isn't overly severe because at higher voltage, the IGBT uses dominate, discrete diode are of a significant higher performance than the body diode of a MOSFET. ICs. The integrated circuit, or IC, is a small chip that can function as an amplifier, oscillator, timer, microprocessor, or even computer memory. An IC is a small wafer usually made of a silicon that can hold anywhere from 100 to million of transistor, resistor, diode, and capacitor. This extremely small electronic can perform calculations and store data using either digital or analog technology. Digital IC use logic gate which work only with value of 1 and 0. A low signal sent to a component on the digital IC will result in the value of 0, while a high signal creates a value of 1. Digital ICs are the kind you will usually find in a computer, networking equipment, and most consumer electronics. Analog or linear IC work with continuous value, This means the component on a linear IC can take a value of any kind of and output another value. The term linear is used since the output value is a linear function of the input. For example, a component of a linear IC may multiply an incoming value by a factor of 2.5 and output the result. Linear IC are typically used in audio and radio frequency amplification. Photon energy. Photon energy is energy carried by a single photon. The amount of energy is directly proportional to the photon electromagnetic frequency and thus equivalently is inversely proportional to the wavelength. The higher the photon frequency, the higher its energy. Equivalent, the longer the photon wavelength, the lower its energy. This is a photon energy formula, E equal to HF, where H is a Planck constant and F is a frequency. Photoconductive effect. An internal photoelectric effect is in which some non-metallic material exhibit a marked increase in electrical conductivity upon an exertion of photon energy. Photon-conducting material include gases that have been ionized by the energy in the photon in a certain crystal. They are used in conjunction with semiconductor material that are ordinarily poor electrical conductors but become distinctly conducting when subject to a photon absorption. The incident photon excites electrons into the conductive band where they move more freely, resulting in increased electrical conductivity. The increase in conductivity occurs because of the additional free charge carriers generated when photon energy are absorbed in the energy transition. The rate at which free carriers are generated at the length of the time they remain in conductive state, for example, their lifespan, determine the amount of the change in conductivity produced by the stream of incident photons. And the last one is a photovoltaic effect. Photovoltaic effect process in which two dissimilar materials in close contact produce an electrical voltage when struck by light or other radiant energy. Light striking crystals such as a silicon or germanium in which electrons are usually not free to move from atom to atom. Within the crystal provide the energy needed to free some electron from their bound condition. Free electrons cross the junction between two dissimilar crystals more easily in one direction than in the other, giving one side of the junction a negative charge and therefore a negative voltage with respect to the other side, just as one electrode of the battery has a negative voltage with respect to the other. The photovoltaic effect can continue to provide a voltage and current as long as the light continues to fall on the two materials. This current can be used to measure the brightness of the incident light or a source of power in an electrical circuit, as is a solar system power. Okay, thank you for listening. Yes.